There is a galaxy aimed at us like a weapon. It has been aimed at us since before the Earth existed, since before the Sun ignited, since before the molecular cloud that would become our solar system had even begun to collapse under its own gravity. For 4.5 billion years, while life crawled out of oceans and built cities and learned to split atoms and pointed radio telescopes at the sky searching for signs of intelligence elsewhere in the universe, while all of that was happening, something was coming. It is 2.537 million light-years away. It contains 1 trillion stars. It is moving toward us at 110 kilometers per second. And here is the thing that should unsettle you, the thing that your mind will resist before it accepts. It has already arrived. The collision has already happened. We are already inside it. Both statements are true. Neither is wrong. You are not safe in the present. You never were. The present is not where you think it is. If confronting uncomfortable truths about the nature of reality is why you're here, subscribe. What follows will not reassure you. The year is 1875, and in Mulberry, Indiana, a child is born into a farming family on the flattest land in America. The land stretches in every direction without relief, without obstruction, and on clear nights the sky above it is dark enough that the Milky Way casts a faint shadow on the ground. The boy's name is Vesto Melvin Slipher. He does not know, and cannot know, that in 37 years he will make a measurement that breaks the existing model of the universe so completely that astronomers will spend a decade refusing to believe his numbers. He does not know that the faint smear of light visible on autumn evenings, the thing his neighbors call the Andromeda Nebula and assume is a gas cloud within our own galaxy, is falling toward him at a speed that, if scaled to human terms, would carry it across the breadth of North America in 43 seconds. He is an infant in Indiana. He is already inside the incoming light, and the galaxy is already closer than it was when the photons now entering his infant eyes departed it 2.537 million years ago. This is not a metaphor. This is the physics. Before we go deeper into the man who measured the unmeasurable, we need to establish one foundational fact about the universe, because everything that follows depends on it, and the fact is so counterintuitive that the mind accepts it linguistically and then quietly rejects it experientially. The fact is this: you cannot see the present. Not of distant objects, not of the moon, not of the sun, not of the nearest star, Proxima Centauri, which is 40.2 trillion kilometers away, not of anything. Every photon that has ever entered your eye was already old when it arrived. The light from the moon takes 1.3 seconds to reach you. The light from the sun takes 8 minutes and 20 seconds. The light from Proxima Centauri takes 4.24 years. The light from Andromeda takes 2.537 million years. What this means is simple and devastating. You are not seeing where these objects are. You are seeing where they were. And the longer light takes to travel, the older your information, and the further the real object has moved from the position in which you observe it. The Andromeda galaxy that every human being who has ever looked at the night sky has seen, the Andromeda galaxy of tonight, this moment, this precise configuration of photons on this detector, departed Andromeda 2.537 million years ago, before our species existed, before Homo heidelbergensis walked the African savanna, before the genus Homo had fully differentiated from its predecessors. The photons you are receiving tonight have been traveling since the Pliocene. The real Andromeda, the Andromeda of tonight, of this second, of the universe's actual present tense configuration, is not where you see it. It is 261,670 light-years closer. It has moved that distance toward us during the time its light has been in transit. You cannot see that it has moved, because the information about its movement has not arrived yet, and will not arrive for 2.537 million years. This is not a problem that better telescopes will solve. The Hubble Space Telescope, the James Webb Space Telescope, any hypothetical instrument of any hypothetical sensitivity, All of them can only receive light that has traveled from its source, and light travels at a fixed speed, and no instrument changes the travel time. The information lag is not a technological problem. It is a structural property of a universe in which information moves at a finite speed. The present is inaccessible. The present has always been inaccessible. Every human being who has ever lived, every observation ever made, every telescope ever pointed at the sky, all of them without exception, looking at the past and calling it now. This is where we begin. And this is the least unsettling thing this documentary will ask you to accept. The Andromeda Galaxy, catalogued as Messier 31, NGC 224, and in older texts the Great Andromeda Nebula, is the nearest large galaxy to the Milky Way. It sits 2.537 million light-years from Earth, a figure established with sub% precision by Rees et al. 2012 using Cepheid variable stars, and subsequently confirmed by multiple independent methods that converge on the same value. It contains approximately 1 trillion stars, compared to the Milky Way's estimated 250 to 400 billion. It is larger than us. It is falling toward us. And according to the most comprehensive gravitational modeling of the local group ever conducted, Van der Merle et al. 2012, using Hubble Space Telescope proper motion measurements, the probability of a direct merger exceeds 95%. This is not speculation, this is measurement. In approximately 4.5 billion years, the merger will begin. In approximately 6 billion years, it will be substantially complete, and the two galaxies will have reorganized into a single large elliptical galaxy that some astronomers have taken to calling Milkomeda, which is a name both useful and faintly absurd, like naming a supernova after a breakfast cereal. But here is the part that the 4.5 billion year figure conceals by its very enormity. The collision already occupies a fixed point in spacetime. It exists. It is real. It has coordinates in the four-dimensional structure of the universe. The question of whether it has happened or not depends entirely on which now you are speaking from. From our now, the only now accessible to us, it is in the future. From a now 6 billion years hence, it will be in the past. The universe does not have a universal now. Every moment is now from its own position in space-time, and then from every other position separated from it by distance. This is the paradox that the title names, and the resolution of the paradox is not comfort. The resolution is the discovery that you have been operating on a false model of time your entire life. We will build that resolution carefully. We will build it through the story of a man in Indiana who spent 13 months of clear nights with his eye at an eyepiece and his cold hands on a spectrograph control, measuring something that no instrument had ever been sensitive enough to measure before, and arriving at a number that the entire scientific establishment found difficult to believe. Vesto Slipher was not supposed to be an astronomer. He enrolled at Indiana University in 1901, not in physics or mathematics, but in mechanics and business, the practical application of a quantitative mind to a world that valued practical things. The Sliffers grew corn and wheat. They were not a family that cultivated impractical enthusiasms. What redirected him was a professor named John Miller, who noticed during a required science course that the young man from Mulberry possessed an unusual quality. He did not merely calculate correctly, he calculated precisely. There is a difference. Correct answers are common among students who understand the material. Precise answers, answers that track and manage and minimize uncertainty at every step, that report results with error bounds, and acknowledge the limits of the instruments used, are rarer, and they indicate something specific about the mind producing them. Miller arranged for Slipher to spend a summer as an assistant at Lowell Observatory in Flagstaff, Arizona, newly built by the astronomer and gentleman scientist Percival Lowell on a mesa above the Ponderosa Pines. Slipher arrived in the summer of 1901 expecting to stay for one season. He stayed for 68 years. Lowell Observatory in 1901 was organized around one principal obsession: Mars. Percival Lowell had spent years convinced, publicly, vociferously, in 3 full-length books, that the faint linear features visible on Mars through his telescope were artificial canals, built by an intelligent Martian civilization to distribute water from the melting polar ice caps to an increasingly arid equatorial region. He wrote with great confidence about the Martian engineers and their planet-wide hydraulic project. He was wrong, and the wrongness would eventually become famous as a textbook example of the observer seeing what they want to see. The canals were optical artifacts, the human visual system's tendency to connect faint, separate features into continuous lines when viewing near the limit of resolution. But Lowell was not stupid. He was a Harvard graduate with a polymath's range and genuine gifts for observation, popularization, and institutional management. His observatory was real, its instruments were excellent, and his interest extended beyond Mars to a class of astronomical objects that were, in 1901, genuinely mysterious: the spiral nebulae. Spiral nebulae were the most contested category in astrophysics at the turn of the 20th century. Through small telescopes, they appeared as faint, fuzzy patches of light, many with visible spiral structure, distributed across the sky in a pattern that clustered toward the galactic poles and avoided the galactic plane in a way that seemed meaningful but resisted explanation. There were thousands of them in the photographic catalogs. What they were, whether they were small gas clouds in protosolar systems within our own galaxy, or vast external systems of stars far beyond the Milky Way, was an open question that had been open since William Herschel first catalogued them in the late 1700s. The philosopher Immanuel Kant had proposed in 1755 that they were island universes, independent galaxies of stars seen at such enormous distances that their individual stars blurred into a diffuse glow. This idea had advocates and opponents in roughly equal measure through the 1800s, and the state of the debate in 1900 was approximately what it had been in 1755. Nobody knew. The instruments were not yet good enough to settle it. The argument against island universes had appeared to gain decisive support in 1885, when a bright star appeared within the Andromeda Nebula, a so-called nova, visible to the naked eye, designated S Andromeda. The calculation was straightforward, and its conclusion was apparently fatal to the island universe hypothesis. If the Andromeda Nebula were truly an external galaxy at an enormous distance, this single star would need to have been intrinsically as bright as the entire Milky Way to be visible from such a distance. That seemed impossible. Therefore, Andromeda could not be that distant. Therefore, it was a relatively local gas cloud. Therefore, it was within our galaxy. This argument was not unreasonable given what was known in 1885. What was not known in 1885 was that S Andromeda was a supernova, not a nova, not an ordinary variable star momentarily brightening, but a catastrophic stellar explosion releasing more energy in a few weeks than the Sun will release over its entire 10 billion-year lifespan. Supernovae can briefly outshine their entire host galaxies. The argument from 1885 that destroyed the island universe hypothesis was built on a failure to recognize the most energetic class of events in the universe, which is a forgivable failure in 1885 and a spectacular irony in retrospect. But in 1901, supernovae were not understood. The argument from S Andromeda still had force. The consensus, to the extent there was one, leaned toward the spiral nebulae being local objects, and Lowell wanted to know if they were rotating. The logic of the measurement Lowell assigned to Slipher was sound. If the spiral nebulae were rotating disks, like the disk of gas from which, according to the nebular hypothesis, the planets of our solar system had formed, then different parts of each nebula would be moving toward and away from the observer at different velocities as the disk turned. This differential velocity should be detectable in the spectrum of the nebula using the Doppler effect. The shift of spectral lines toward shorter wavelengths, blue, when the source approaches, and toward longer wavelengths, red, when it recedes. The size of the shift encodes the velocity. The problem was sensitivity. Stars were bright. Their light concentrated into point sources that could be passed through a spectrograph and spread into a spectrum with sufficient intensity to measure the positions of absorption lines. Spiral nebulae spread their light across extended areas of sky, diluting it to the edge of detectability. The spectrographs of 1901 were not fast enough. The photographic plates were not sensitive enough. Exposures long enough to register a usable spectrum from the brightest spiral nebula, the Andromeda Nebula, would need to be measured not in minutes but in hours, and possibly in multiple hours across multiple nights, with the instrument returning to precisely the same position each time to accumulate signal on the same portion of plate. The precision required was extraordinary, so was the patience. Slipher was constitutionally suited to both. He began his attempts to spectroscope the Andromeda Nebula in earnest around 1909. The instrument available to him was the 24-inch Clark refractor, the observatory's primary telescope, fitted with a spectrograph of his own ongoing modification. Flagstaff sits at 2,106 meters elevation. The winter nights, which offered the steadiest atmosphere and the longest darkness, were severe. Thermometers attached to the telescope casing regularly read below -20 Celsius. The dome was open to the sky, unheated, because heat from the dome structure distorts the atmosphere above the opening and degrades the seeing. Slipher worked in these conditions in heavy clothing with cold hands, making fine adjustments to a spectrograph that needed to be aligned to within fractions of a millimeter to place the nucleus of Andromeda precisely on the spectrograph slit. The first attempts failed. The spectra were too faint. The exposure times were insufficient. The signal was buried in the noise of the photographic emulsion. Slipher went back to his workshop. Lowell Observatory in this era was a small institution where astronomers were expected to build and maintain their own instruments, and redesigned his spectrograph camera. He replaced the existing camera lens with a faster one, shorter focal length, wider aperture, concentrating the nebular light onto a smaller area of plate and dramatically increasing the signal-to-noise ratio. It was the right intervention. The faster camera was the key. But even with the improved instrument, the exposures required were long. Not one night but multiple nights. Not 1 hour but 6, 8, sometimes 10 hours of accumulated exposure, with the telescope returned to the identical position each clear night, and the plate reinserted into exactly the same position to continue building signal on the existing image. This required guiding precision that demanded constant attention. An astronomer with his eye at a guiding eyepiece, manually correcting the telescope's tracking to keep the target positioned on the slit, for hours at a time, in sub-zero temperatures, while the plate inside the spectrograph accumulated its faint signal. The predecessors who had tried and failed were not incompetent. Edward Fath at Lick Observatory in California attempted the same measurement in 1909 with similar instruments and produced spectra too faint to yield reliable velocity measurements. Julius Shaner at the Astrophysical Observatory in Potsdam had obtained a rough spectrum of Andromeda in 1899, good enough to determine that it was probably composed of stars, similar in spectral type to the Sun, rather than hot gas, but not sharp enough in its spectral lines to measure velocities with the precision the question required. Francis McLean in England had tried and produced nothing usable. The measurement was at the edge of what early 20th century technology could deliver, and the edge was sharp. Slipher's modification pushed the edge. Over 13 months of every usable clear night at Flagstaff, which in northern Arizona's high-altitude desert is most nights but not all nights, because weather cooperates with history only occasionally, he accumulated exposure after exposure, building the signal. On the night of September 17, 1912, Slipher opened the shutter on his modified spectrograph pointed at the nucleus of the Andromeda Nebula. The exposure lasted several hours through a night of good seeing. The atmosphere was stable, the stars sharp, the spectral lines well-defined. The next morning in the darkroom, he developed the plate. The spectral lines were shifted. They were shifted toward the blue end of the spectrum. Blue shift. The source was moving toward the observer. This was not unusual in itself. Many stars showed blue shift. What was unusual was the magnitude. Slipher measured the shift 3 times with his measuring engine, the mechanical device used to read positions of spectral lines on photographic plates with micrometer precision. He had a colleague check his measurement independently. The line positions were unambiguous. The velocity they encoded was 300 kilometers per second, the highest velocity ever measured for any astronomical object in the history of spectroscopy. Slipher did not immediately publish. He took additional exposures. He checked his wavelength calibration standards, the reference lines from known laboratory sources that established the zero point of his velocity scale. He examined the plates for systematic errors, distortions of the emulsion, misalignment of the slit, errors in the calibration arc. He found none. The number held. 300 kilometers per second toward Earth. For comparison, the fastest stars in the Milky Way at that time were known to move at velocities of perhaps 50–80 kilometers per second relative to the Sun. A velocity of 300 was not just fast. It was in a different category, either an extraordinary outlier in local stellar dynamics, or evidence that the Andromeda Nebula was not a local object at all, but something so distant and massive that the ordinary velocity scales of our galaxy did not apply. Slipher wrote up his results carefully. He presented them at the American Astronomical Society meeting in August 1914 in Evanston, Illinois. The audience of professional astronomers, people who measured velocities of tens of kilometers per second and considered 100 kilometers per second unusual, heard the number 300 and gave him a standing ovation, not because they understood the implications. Because the technical achievement was immediately and obviously extraordinary. He had measured the unmeasurable. The number was real. Over the following decade, Slipher extended his work. He had a method now, a refined instrument, hard-won experience with the challenges of nebular spectroscopy. He turned his spectrograph on spiral nebulae across the sky, measuring their velocities one by one, each measurement requiring days to weeks of clear night exposure time. By 1917, he had measured 25 spiral nebulae. By 1922, he had 41. By the mid-1920s, he had velocities for 45 spirals. The pattern was striking and, to anyone paying careful attention, deeply strange. Of the 45 spiral nebulae, 43 showed redshift. They were moving away from the Earth, not slowly, at velocities ranging from a few hundred to more than 1,800 kilometers per second. Only 2 showed blue shift. Only 2 were approaching: the Andromeda Nebula and the Triangulum Galaxy, M33, which we now know is gravitationally associated with Andromeda and part of the same incoming system. The 43 receding objects were not receding randomly in all directions, as gas clouds bouncing around the Milky Way would move. They showed a systematic pattern. The fainter ones, the ones presumably farther away, tended to recede faster, and the velocities themselves, several hundred to nearly 2,000 kilometers per second, were utterly inconsistent with membership in the Milky Way. Stars in our galaxy did not move at 1,800 kilometers per second relative to us. If they did, they would escape the galaxy's gravitational field entirely. These objects were either moving fast enough to escape our galaxy, and thus were not part of it, or they were moving with something else, something larger, something acting on a scale that included our galaxy as a small component. Slipher had the velocities. He did not have the distances. Without distances, He could not construct the relationship that would later explain the systematic recession pattern. The universe is expanding, and the recession velocities of distant galaxies are proportional to their distances because the space between them is stretching, carrying them apart like dots on an inflating balloon. This insight, and the observational proof of it, would come in 1929 from Edwin Hubble, using distance measurements from Cepheid variable stars in the same spiral nebulae whose velocity Slipher had measured. Hubble's law is named after Hubble. The velocities in the dataset that proved it came almost entirely from Slipher. This is one of the more cleanly documented injustices in the history of astrophysics, but it is not the main story. The main story is what all those velocities, assembled and interpreted, revealed. The universe is not static. It is not bounded. The spiral nebulae are not local gas clouds. They are external galaxies, island universes exactly as Kant had imagined in 1755, confirmed 174 years later by a farmer's son from Indiana with cold hands and a modified spectrograph. The Milky Way is not the universe. It is one galaxy among hundreds of billions, embedded in an expanding cosmos of incomprehensible scale. And within this cosmos, one nearby galaxy, the nearest large one, the one visible with the naked eye on clear autumn nights, is gravitationally bound to us, not receding, approaching, on a trajectory that has been locked in by the mathematics of gravity since before either galaxy had formed its current structure. Slipher's 300 kilometers per second, refined by subsequent measurement to 110 kilometers per second in the radial direction, is the number at the center of everything that follows. He measured it in the dark, in the cold, over 13 months of clear nights, with an instrument he had built himself. He died in Flagstaff in 1969, at 93 years old, having seen the universe transform from a cozy, bounded neighborhood into an expanding immensity of hundreds of billions of galaxies. He spent 68 years in the same observatory, where he had arrived expecting to spend one summer. He left behind a life's work that changed the understanding of the cosmos more profoundly than almost any other individual contribution of the 20th century. He never, in any surviving letter or interview, commented on what it felt like to know that one of those galaxies was falling toward us. Some people are calibrated for measurement. The dread is someone else's job. To understand the paradox at the center of this documentary, the collision has already happened. The collision has not happened yet. Both are true. You need to understand three things. What time actually is in a universe with a finite speed of light? What a galaxy merger actually looks like at the scale of stars versus the scale of galaxies, and what it means to speak of a single event existing in spacetime regardless of whether any observer has yet witnessed it. We will build this understanding in three layers. Each layer uses an analogy that is precisely scaled to the physics. None of them are loose metaphors. They are calibrated models of a physical reality, and the vertigo they create is not confusion. It is accurate comprehension. You know this experience. You are outside during a thunderstorm, lightning flashes, you count seconds, thunder arrives. The lightning bolt and the thunder it produces are the same event, a single discharge of atmospheric electricity occurring at a single location, at a single moment. The discharge releases energy across the electromagnetic spectrum, visible light and ultraviolet radiation, simultaneously with the creation of a rapid pressure wave in the surrounding air. Both outputs leave the same location at the same instant, but they travel at different speeds. Light moves at 299,792 kilometers per second. Sound moves at approximately 0.343 kilometers per second. By the time sound has crossed 3 kilometers to reach you, light has been there for 8.7 seconds. During those 8.7 seconds, you did not see the lightning bolt as something 8.7 seconds old. You saw it as something that had just happened as present tense, as immediate as now. And then the thunder arrived and confirmed it. But you were, from the first photon to the last, watching the past. The lightning was already history when the light reached your eye. You called it now because you had no other frame. Because for all experiential purposes, the distinction between a thing that happened 1/3 of a second ago and a thing happening now is irrelevant to ordinary human life. Scale this up by 9 orders of magnitude. The light arriving from Andromeda tonight left its source 2.537 million years ago. You call it Andromeda, now the same way you call the lightning bolt now, because it has just arrived, because it is the most current information you have, because there is no other frame available to you. But the thunder from the same event, the gravitational wave signal, the full electromagnetic profile of Andromeda's actual present tense state, has not arrived. It will not arrive for 2.537 million years. Now here is the part of the thunderstorm analogy that most versions leave out. With the lightning bolt, you know you are watching something 8.7 seconds old. You know this because you know how fast sound travels and how far away the strike was. You can correct for the delay. You know where the lightning struck, not just where you saw it from. You have enough information to reconstruct the event's true location and timing. We have the same capability with Andromeda. We know how fast light travels. We know how far away Andromeda is. We know how fast it is moving toward us. We can calculate where the real Andromeda is right now, the Andromeda of the universe's actual present tense configuration, not the Andromeda of the 2.537 million year old photograph. We can calculate it. We cannot observe it. We cannot confirm it. We cannot receive any signal from it that would update the photograph. All we can do is extrapolate from old light and known physics. The calculation says, the real Andromeda right now is approximately 1.37 million light-years away, not 2.537 million. It has moved 1.17 million light-years toward us during the time its light has been in transit. You have never seen it at this distance. No human being has ever seen it at this distance. No instrument has ever detected it at this distance, and none will for 1.37 million years when the light now leaving the real Andromeda finally arrives. The lightning struck, the thunder is still coming. This is the first layer. The universe we observe is always the past, and the present is always ahead of us, unreachable by definition, calculable only by extrapolation. Analogy 2, the ocean and the ships, what a merger actually is. The word collision triggers a specific physical intuition. Two objects approach each other, they meet, they impact. Material deforms, compresses, transfers momentum. This is what collision means in ordinary human experience: cars, billiard balls, fists, tectonic plates. A galaxy merger is not this. To understand what it is, you need an analogy that captures the defining feature of galaxies, which is the feature most people intuitively underestimate: the emptiness. A galaxy is almost entirely empty space. The stars within it are tiny relative to the distances between them. The Sun has a diameter of 1.39 million kilometers. The distance from the Sun to the nearest other star, Proxima Centauri, is 40.2 trillion kilometers, roughly 30 million solar diameters. If you scaled the Sun down to a grain of sand 1 millimeter across, Proxima Centauri would be another grain of sand 30 kilometers away. Between them, nothing. Vacuum, the interstellar medium, tenuous gas and dust at densities that would qualify as hard vacuum in any laboratory on Earth. Now build an analogy from this. Imagine an ocean, not a small ocean, an ocean whose surface area equals roughly the cross-section of our galaxy. On this ocean, ships are distributed at average separations of 50 kilometers from each other. These ships are stars. Each ship is tiny relative to the spacing. If you were aboard one, you would see other ships on the horizon, but mostly you would see water. Vast, featureless water in every direction, with distant ships barely visible at the edge of perception. Now imagine a second ocean, another vast body of water, approaching the first one from 50 million kilometers away. These two oceans are moving toward each other at 110 kilometers per second. They will reach each other in approximately 4.5 billion years. What does their collision look like? Not what you expect. The oceans will interpenetrate. The waves of one will pass through the waves of the other. There will be turbulence, tidal forces disrupting the surface structure of both oceans, rogue waves forming at the intersection of the two wave systems, complex interference patterns, regions of unexpected calm and unexpected violence. But the ships, the stars, will mostly pass each other. Two ships moving through interpenetrating oceans are unlikely to collide directly, because ships are small relative to their separation, even in an ocean full of ships. In the Andromeda merger, the stellar separation within each galaxy is so large relative to stellar size that the probability of any two stars colliding directly, star to star, physical impact, is estimated at less than 1 in a million for any given star. Our Sun will almost certainly not strike any Andromedan star. The stars of both galaxies will pass through each other's stellar fields the way a swarm of bees passes through another swarm. The individuals interact gravitationally, deflecting from their previous paths, acquiring new velocities, being redistributed into a new overall structure, but not physically colliding in the billiard ball sense. This is the reassurance the universe offers. It is accurate and insufficient. Because here is what the ship analogy conceals. The ocean is not empty. Between the ships, between the stars, there is weather. Gas and dust filling the interstellar medium in vast, diffuse clouds at densities ranging from a few atoms per cubic centimeter in the warm phases to millions of atoms per cubic centimeter in the densest molecular cloud cores. These clouds are large, not ship large, ocean large. They fill vast volumes of space, overlapping and interpenetrating each other, structured in complex filamentary networks that trace the galaxy's gravitational architecture. Unlike stars, these gas clouds cannot simply pass through each other when the two galaxies merge. They are not discrete objects separated by vast empty spaces. They are the ocean itself, the medium in which the ships float. When two oceans interpenetrate, the water collides. The gas clouds of the Milky Way and Andromeda will collide directly, physically, cloud to cloud, with the full hydrodynamic violence of two masses of interstellar gas meeting at 110 kilometers per second. This collision compresses gas. Compressed gas forms stars. The merger will trigger what astronomers call a starburst, a period of dramatically accelerated star formation in which the combining galaxies generate new stars at rates that exceed their pre-merger rates by factors of 10, 100, or more. We can observe this happening in other merging galaxy pairs right now. The antennae galaxies, NGC 4038 and NGC 4039, currently mid-merger at a distance of 45 million light-years, display starburst activity across their overlapping regions, with infrared luminosities indicating star formation, rates many times normal. Their interacting gas clouds compressed into chains of young star clusters blazing blue-white along tidal filaments visible in images from the Hubble Space Telescope. Starburst regions are violent environments. Massive stars, the kind that form in compressed starburst gas, burn through their fuel in millions of years and die as supernovae. A starburst generates supernovae at rates far above galactic average. Supernovae produce shock waves, radiation, and heavy element enrichment of the surrounding medium. The merger does not just reorganize the galaxy's gravitational architecture, it detonates it. The Van der Merle et al. 2012 study includes probabilistic estimates of where our solar system will end up after the full merger. Currently, the Sun sits approximately 26,000 light-years from the galactic center. After the merger is complete, after the two galaxies have interpenetrated, reorganized, and settled into a new equilibrium, the study estimates a 12% probability that the Sun will be scattered to a position significantly different from its current one. Specifically, a 3% probability of being ejected to more than twice the current galactic radius. Not into the starburst core, probably, but not guaranteed to stay where it is. 12% is not zero. 3% is not zero. These numbers have no personal relevance to anyone alive or born in the next several million years, but they are the numbers. Write them down. This is the analogy that contains the resolution to the paradox. The reason the collision has already happened and also hasn't. The reason both statements are true without contradiction. Imagine a river, not a metaphorical river, a specific river, photographed from an airplane at a precise moment, 2:00 p.m. on a specific day. The photograph is taken with a perfect camera, infinite resolution, zero distortion. Every molecule of water surface is captured exactly as it was at 2:00 p.m. You look at this photograph at 4:00 p.m. Is the photograph accurate? Yes. It accurately represents the river at 2:00 p.m. with perfect fidelity. No part of it is wrong. The curve of the bank, the position of the boulders, the patterns of turbulence where water moves over submerged rocks, all of it is true. Is the photograph current? No. 2 hours have passed. Every molecule of water shown in the photograph has moved downstream. The river is where it is at 4:00 p.m., not where it appears in the photograph. Now the critical question, where is the river? Not in the photograph. The photograph shows where the river was, not where it is. You know roughly where the river is because you know rivers move downstream, and you can estimate how far a river moves in 2 hours. But the photograph does not show you that. The photograph is a record of a past state, delivered to your eyes in the present. Now extend the exposure time. Instead of 2 hours, the photograph was taken 2.537 million years ago. And the only camera you possess is one that requires light to travel from the subject to the lens, at the only speed light knows how to travel. You are looking at a 2.537 million year old photograph of Andromeda. Not a facsimile, not an approximation, the literal photons, the actual electromagnetic radiation emitted or reflected by stars in Andromeda 2.537 million years ago, arriving at your detector tonight. The photograph is accurate. The data is real. Every spectral line, every measured velocity, every photon is genuine information about Andromeda at 2.537 million years ago. But you are asking where Andromeda is, and the photograph cannot tell you. Here is what the photograph does tell you. Andromeda was, 2.537 million years ago, moving toward us at 110 kilometers per second. Physics is deterministic at the scale of galaxy dynamics. Given a position and a velocity and given the gravitational field of the local group, the trajectory is calculable. You can ask, given that Andromeda was at position x moving at velocity v at time t, where is Andromeda now? The answer is approximately 1.37 million light-years away, closer by 1.17 million light-years than what you observe. And the future trajectory, extrapolated forward from now, from the real now, the inaccessible now, the now you can calculate but not observe, points toward merger in approximately 4.5 billion years. Now here is the thing, the river analogy is built to deliver. The river exists in all its states. The river at 2:00 p.m. exists. The river at 4:00 p.m. exists. The river tomorrow morning exists. These are not competing truths. They are the same river at different coordinates in time. The river's state at each moment is fixed. It was what it was when it was it, and that cannot be changed from any other temporal vantage point. The photograph captures one state. The present captures another. Both are real. Both are the river. The Andromeda merger exists in the same way. It has a location in spacetime, a set of four-dimensional coordinates marking the moment when the leading stars of both galaxies begin to interpenetrate each other's stellar fields. That moment exists. It is fixed. It is real. It has always been real, from the moment the initial conditions of the local group were established after the Big Bang. Whether that moment is in your past or your future depends on your position in spacetime. From our current position, 2026 CE, Sol system, Milky Way, the merger is in the future. From a position 5 billion years hence, it will be in the past. From neither position can you access the event directly. You can only receive light from it, and light takes time to travel. The collision is fixed. It is not approaching. It is not threatening. It exists the way all events exist in spacetime, as a fact about the universe that is what it is regardless of the perspective from which it is viewed. The river is already at 4:00 p.m. The photograph still shows 2:00 p.m. Both are true. The collision has already happened in the sense that its coordinates in spacetime are occupied by a real event. The collision has not happened yet in the sense that those coordinates are in our future light cone, not our past light cone. We cannot observe the future. We cannot observe the present. We can observe only the past, the long, receding past that we have always called now, because we had no word for what we actually mean, which is the most recent information we have received, already old before it arrived. Let us repeat the core insight 3 times, in 3 registers, because it is the kind of insight that the mind accepts and then erases, quietly and without announcement, because it is too destabilizing to hold in ordinary consciousness. First register, clinical. The present state of any sufficiently distant object is not observable. The information encoding that state travels at the speed of light and has not arrived. The Andromeda we observe is 2.537 million years old. The real Andromeda is 1.17 million light-years closer than the Andromeda we observe. Second register, physical sensation. Look at the night sky. Every photon touching your eye from every star, from every galaxy, from every extended smear of light in every direction is old. Not metaphorically old, literally old. Traveling light that left its source before you existed and arrived after you opened your eyes. You are standing in a rain of ancient signals. The sky is not showing you the universe. It is showing you the universe's past, organized by distance. Nearby objects in the recent past, distant objects in the deep past, all arriving simultaneously at your retina and all interpreted, without hesitation, as now. Third register, the paradox. The collision exists. Its spacetime coordinates are occupied. The event is as real as any event that has already occurred. Whether it is in your past or your future depends only on which now you mean. You can only access your own now, which is always the same point in spacetime, which means the collision is always, for you, in the future, right up until it is in your past, at which point you will know it happened because the light will have arrived and you will see, for the first time, what the universe already knew. This is not dread. This is the structure of a universe governed by the speed of light. The dread comes from what it implies. Let us now be systematic about the exits. Every mind encountering the physics laid out in Act 3 will search for a way out. This is not a failure of rationality. It is rationality operating correctly, identifying threats, generating counterarguments, testing escape routes. The exits exist. They feel solid. They are not. We will examine each one in turn under full illumination until the room has no remaining doors. The first escape is scale, 2.537 million light-years, 4.5 billion years. These numbers are so large, the argument goes, that they are simply not meaningful to human experience. The individual human life is 80 years. Human civilization is 12,000 years old. The merger is 4.5 billion years away. The ratio is 56 million to 1. This is too large to be meaningful. It is in another category. It does not apply. This argument fails at 3 points. First, the dread appropriate to this situation is not practical dread. It is not the dread of a tiger in the room, of a diagnosis, of a war. It is ontological dread, the dread that attaches not to consequences but to the nature of the structure within which consequences occur. The collision has been approaching since before the Earth formed. The arithmetic determining it was written into the initial conditions of the local group. The universe did not consult anyone. It did not leave a note. It simply set the initial conditions and ran the equations. The discomfort this creates is the discomfort of discovering that you are living inside a machine of incomprehensible scale that is executing a program you did not choose, cannot alter, and will not outlive. This discomfort does not depend on personal danger. It is the same discomfort produced by the heat death of the universe, an event 10,100 years in the future that will affect no one currently alive and will never affect anyone who will ever be born. And yet the knowledge of it has weight. Knowledge of inevitable ends has weight regardless of the timescale. This is a property of consciousness, not of clocks. Second, the distance that makes the collision irrelevant is the same distance that makes the present inaccessible. You cannot have the comfortable irrelevance of the merger's remoteness without accepting the uncomfortable inaccessibility of the present that remoteness implies. The scale cuts both ways. If 2.537 million light-years is too far to matter, it is also too far to see current reality. You are not living in a comfortable present with an irrelevant distant danger. You are living in a permanent past, unable to observe the actual present, receiving ancient light and calling it now. The scale does not protect you from the danger. It simply removes you from the information. Third, the Van der Merel et al. 2012 study quantifies a 12% probability that our solar system will be scattered to a dramatically different galactic position during and after the merger. A 3% probability of ejection to more than twice the Sun's current galactic radius. These are not zero. In a universe that has already produced 5 mass extinction events on Earth, none of which consulted the biosphere before proceeding, a 12% probability attached to an event of this magnitude is not a number that the word irrelevant can comfortably contain. Exit 1 is closed. Exit 2, we will already be dead. The second escape is chronological deflection. The Sun will exhaust its hydrogen in approximately 5 billion years, expand into a red giant, and incinerate the Earth before collapsing into a white dwarf. This will happen roughly 500 million years before the merger begins in earnest. We will be gone. The collision is a moot point for a dead species on a vaporized planet. This is chronologically accurate and logically insufficient. The argument assumes that human existence, or its biological, technological, or otherwise descended successors, is bounded by the Earth's lifespan. This assumption is made from the perspective of a species that has achieved spaceflight within the last 65 years of a 300,000-year existence, and it is an assumption of spectacular myopia. Whether humanity or its successors will exist in 5 billion years, and in what form and where, is not knowable. What is knowable is that a species capable of moving beyond its home planet at any point in the next billion years is not obviously constrained by the death of that planet's star. The argument, "will be dead," requires a confidence in our long-term extinction that the evidence does not support. But the deeper failure of this exit is philosophical, not astronomical. The claim that the merger is irrelevant because we will be dead before it happens has never, in the history of human thought, successfully neutralized the weight of a known inevitable end. You will die. Every person you have ever known will die. Every species currently alive will eventually go extinct. The sun will expand. The universe will decay. None of this becomes weightless because the timeline is long. The knowledge of it exists now, in a mind that exists now. The weight of the knowledge does not require proximity to the event. It requires only the capacity to know. The merger is not a future problem. It is a present fact about the universe you currently inhabit. The fact is that you live in a galaxy that is gravitationally bound to another galaxy that is falling toward it on a trajectory fixed by the mathematics of gravity. This is a property of the universe you are in right now, tonight, as you read these words. The fact that its consequences will manifest in the deep future does not change the fact's present tense existence. Exit 2 is closed. Exit 3, the measurements could be wrong. The third escape is scientific humility. Measurements can be in error. Models can be revised. The history of science contains confident predictions that turned out to be wrong. Maybe the velocity is not 110 kilometers per second. Maybe the models are missing a factor. Maybe this is all more uncertain than the authoritative numbers suggest. This is the most intellectually defensible exit and the most thoroughly blocked. The radial velocity of Andromeda toward us has been measured continuously since 1912. Slipher's original measurement of 300 kilometers per second was refined as instrumentation improved, and as the distinction between radial and transverse velocity components was understood. The modern accepted value of 109 plus or minus 4 kilometers per second in the radial direction, toward away from us, has been confirmed by independent spectroscopic measurements at multiple observatories across multiple decades, using multiple different spectral features and multiple independent calibration methods. The measurements agree. More critically, the Van der Merel et al. 2012 study added a dimension of measurement that had never before been achieved: the transverse velocity of Andromeda, its sideways motion across the sky, perpendicular to our line of sight. This is the measurement that determines whether Andromeda will hit us directly, graze us, or pass wide. The transverse measurement required detecting proper motions of stars in Andromeda of 47 microarcseconds per year, an angular motion equivalent to observing an object move 1 millimeter sideways from a distance of 57 million kilometers. This was achieved using the Hubble Space Telescope over a baseline of 57 years, tracking the positions of thousands of individual stars in 3 separate fields of the Andromeda halo. The transverse velocity measured, approximately 17 kilometers per second. This is small compared to the radial velocity, meaning Andromeda is moving almost directly toward us, not at a large angle. This is why the collision probability exceeds 95% rather than being a near miss. If the transverse velocity were larger, if Andromeda were approaching at a large angle, the two galaxies would swing past each other. The small transverse velocity means the approach is nearly head-on. The physics predicting the eventual merger is the same physics, Newtonian gravity, general relativity, that predicts the orbit of the Moon, the trajectories of the Voyager probes, the behavior of binary stars and galaxy clusters. It is the best-tested physical theory in the history of science. To reject the merger prediction requires rejecting a physics framework that has passed every observational test ever applied to it. The measurements are not wrong. The physics is not wrong. Exit 3 is closed. Exit 4, the stars actually collide. The fourth escape is the one offered by the physics itself. The stars won't hit each other. We established this in the Ship-Handoshan analogy. The solar system will survive the merger. The Earth will not be physically struck by an Andromedan star. This is not a merger in the sense of two solid objects colliding. It is a gravitational reorganization. We should relax. This exit closes not because the underlying fact is wrong. It is correct that direct stellar collisions will be extremely rare, but because it addresses the wrong question. The merger is not primarily dangerous because of stellar collision. The merger is existentially significant because of what it reveals about the structure of the universe in which we live. The solar system surviving the merger physically intact, our sun continuing to shine, the Earth's orbit remaining stable, the basic physical substrate of life continuing to exist, does not change the following facts. The universe is a machine that proceeds without reference to the preferences, persistence, or existence of consciousness within it. The Andromeda merger was not scheduled around us. It was not checked against our survival requirements. It has been proceeding according to gravitational arithmetic since before the Earth existed, and it will continue proceeding according to gravitational arithmetic after the last human mind has gone dark. Whether we survive it physically is a narrowly practical question. The larger question, what does it mean to be a temporary configuration of atoms in a universe that is executing programs of incomprehensible scale at speeds we cannot track, is not answered by the stars won't collide. Furthermore, the starburst triggered by the gas cloud collision will flood large volumes of the merging system with radiation. The Van der Merle study's 12% probability of significant solar system displacement is not evenly distributed across all merger scenarios. It reflects the range of possible outcomes, some of which place the solar system in significantly more hostile environments than the current one. The stars won't hit us directly. The universe will still be doing what it is doing. Exit 4 is closed. Exit 5. This knowledge doesn't change anything. The fifth escape is pragmatic. Knowing about the Andromeda merger changes nothing about daily life. The sun will rise tomorrow. Food will still need to be grown. Relationships will still require attention. The abstract fact that two galaxies are bound to merge in 4.5 billion years does not alter any practical decision in any human life. Knowing it produces no actionable information. It is philosophically interesting but practically inert, and practically inert information can safely be set aside. This escape is the most commonly used and the most revealing of what the escape is actually doing. It is not an argument, it is a preference for not knowing. This knowledge doesn't change anything, translates accurately to I would prefer not to have this knowledge active in my consciousness because its presence is uncomfortable. This is a legitimate human response. It is not a logical refutation of the knowledge's significance. The same argument was available to every previous generation that discovered an uncomfortable fact about the universe. That the Earth is not the center of the solar system, that the solar system is not at the center of the galaxy, that the galaxy is not the center of the universe, that the universe has no center, that the universe is expanding, that the expansion is accelerating, that the observable universe contains 200 billion galaxies, each containing hundreds of billions of stars, that our entire planet is a mote of dust in a system that is itself a mote of dust in a galaxy that is itself unremarkable in a cluster of galaxies, that is itself unremarkable in a supercluster, that is itself one of millions. At each stage, the argument, this doesn't change anything practically, was available. At each stage, it failed as a philosophical response to the actual weight of the discovery. The knowledge changes how we understand where we are. Where we are is the most fundamental fact about any consciousness. Changing it changes everything that consciousness is oriented toward, even if it changes no calendar appointments. Exit 5 is closed. Exit 6. Conscious experience is exempt from physical processes. The sixth exit is the oldest. Some form of human consciousness, soul, spirit, awareness, subjective experience, divine participation, exists in a category separate from the physical processes described by physics, and this category carries protections or meanings that galactic collisions cannot extinguish. This documentary does not adjudicate questions of metaphysics or theology. It does not have access to information relevant to claims about the ultimate nature of consciousness or its relationship to physics. What it can say is, every physical measurement ever made of the universe has found it to be consistent with a model in which physical processes operate by the same rules everywhere, on all scales, without exception or exemption. No physical measurement has detected a layer of reality that exempts conscious beings from the consequences of physical processes. Mass extinctions have occurred on Earth 5 times in the fossil record. None of them appear to have been modulated by the presence of consciousness in the species they eliminated. Stars have exploded throughout the galaxy. None of them appear to have been warned off by the existence of life in neighboring systems. The physical universe, as measured, is indifferent, not hostile. Indifference is not hostility, not meaningless in any settled sense. The question of meaning is one that physics cannot answer in either direction. Simply, not organized around the preferences or continuation of any particular configuration of matter. If exit 6 leads somewhere, the map to it is not available in any physical measurement. The door has no handle on the physics side. Exit 6 is closed. What remains when all 6 exits are closed is not despair. Despair requires a prior expectation of safety that has been disappointed. What remains is revision. The model most human beings operate on, implicitly as the background assumption of consciousness, is a model in which the present is accessible, the universe is roughly human-scaled, and the future is open and malleable. This model is false. It has been false since the first moment of cosmic time. It will be false until the last observer. The true model is: the present is inaccessible. The universe operates at scales that make human experience a rounding error. The future contains, with greater than 95% certainty, the merger of our galaxy with a trillion-star system whose light reaches us 2.537 million years after it departs. This model is not comfortable. It is not supposed to be comfortable. It is supposed to be accurate. The universe described by this model is vast, cold, ancient, and indifferent. It is also the only universe. There is no other universe in which the physics works differently and the Andromeda merger doesn't happen and the present is observable and scale is human proportioned. There is only this one, running on these rules, producing this outcome. We are in it. We have always been in it. The galaxy was falling toward us when we were fish, when we were mammals, when we were hominids, when we were the species that first looked up at the faint smear in Andromeda and felt wonder. The wonder and the dread are the same thing, seen from different distances. We began with a galaxy aimed at us like a weapon. We should be more precise now after everything. A weapon implies intent. Andromeda has no intent. It has no knowledge of our existence. It cannot know because nothing in it has sent a signal that has reached us, and nothing in us has sent a signal that has reached it. The light currently reaching Andromeda from Earth, if anything in Andromeda is sensitive to light from Earth, left Earth 2.537 million years ago. It carries no information about human beings. It carries information about the Pliocene epoch, about whatever electromagnetic radiation was being produced by early hominids and volcanic activity and lightning and solar reflection from an Earth that had not yet invented fire. Andromeda does not know we are here. It is falling toward us because its velocity relative to the Milky Way is insufficient to escape the combined gravitational field of the local group. This is not malice. It is arithmetic. Two masses, a separation, a relative velocity, a solution to a differential equation that was written into the initial conditions 13.8 billion years ago. The arithmetic has been running since the universe cooled enough for gravity to dominate. The solution was determined. It is being executed at 110 kilometers per second in the radial direction and approximately 17 kilometers per second in the transverse direction, converging on a point in spacetime that exists with the same fixity as any point in the past. The arithmetic does not know we are inside one of the terms. The 12-year-old in Mulberry, Indiana, looking at the Milky Way in the dark flat field of his father's farm, was already inside the incoming light. The photons from Andromeda that struck his retinas that night had left Andromeda before his species existed. They encoded a state of the universe 2.537 million years in the past. They carried no information about the collision to come. They were simply old light from an old source, arriving on schedule as they had been arriving at the Earth's surface since before the Earth existed, unobserved for 4 billion years, and then observed by creatures who gradually built the instruments and the conceptual framework to understand what they were looking at. What they were looking at was the past. What they were looking at was a galaxy already closer than the image suggested, already in a state they could not observe, already executing the trajectory their descendants' instruments would eventually measure. Slipher's 13 months of cold nights, his modified spectrograph, his measuring engine, his plate of September 17, 1912, all of it brought human consciousness to the point of knowing, of receiving the information and understanding what it encoded, of hearing, for the first time in the language of spectral line positions and Doppler mathematics, that something was coming. He was not the first to look at the light. He was the first to listen to what it was saying. Look at the night sky, if you are somewhere that allows it. Andromeda is visible from the northern hemisphere on autumn evenings, near Cassiopeia, a faint smear roughly 6 times the apparent diameter of the full moon but far dimmer. The light too spread out to concentrate into brightness, requiring dark skies and patient eyes to detect. The Persians called it the little cloud. Medieval Arab astronomers observed and recorded it. Charles Messier catalogued it as object number 31. Every human civilization that looked at the northern sky in autumn saw it, though few of them knew what it was. What it is: a trillion stars organized by gravity into a disk 220,000 light-years in diameter, tilted toward us at an angle of approximately 77 degrees, containing enough mass to exert gravitational dominion over the surrounding volume of space, moving toward us at 110 kilometers per second. What you are seeing when you see it: a 2.537 million-year-old image of that system, delivered by the only available carrier at the only available speed, showing you the configuration of those trillion stars at a moment before your species existed. The real Andromeda, the Andromeda of tonight, of this actual universal present, is 1.37 million light-years away. You have never seen it there. No one has. The light that would show it to you there has not arrived yet. It is currently somewhere between Andromeda and Earth in transit, moving at the speed of light through the intergalactic medium, carrying information about a galaxy that none of us will ever see until 1.37 million years have passed. This is the condition of all observation of all distant objects. It is the condition of consciousness in a universe with a finite speed of light. It is not a problem to be solved. It is the shape of the cage. We are, each of us, a brief and local concentration of matter that has achieved the unusual property of being able to model the universe that contains it. We have built instruments that extend our senses across billions of light years. We have developed mathematics that can describe the behavior of spacetime itself. We have looked at a faint smear of ancient light and decoded, from the positions of spectral lines on a photographic plate, that it is moving toward us at 110 kilometers per second, and from that number, using centuries of accumulated physical understanding, calculated when and how it will arrive. This is an extraordinary achievement. It is the thing that distinguishes us from every other known configuration of matter in the observable universe. We know where we are. We know, approximately, what will happen to us. We know the scale of the thing we are embedded in. We know the trajectory of the thing that is falling toward our galaxy. We know all of this, and we can do nothing with the knowing except know. The collision will happen. The spacetime coordinates of its beginning are occupied. They were occupied before Slipher made his measurement, before the first human being looked up, before the Earth formed. The collision existed as a future event from the moment the local group's initial conditions were established, and it has been approaching its execution ever since, at 110 kilometers per second, decelerating slightly as gravity does its work across the growing distance, always falling, always converging, moving through a present that neither we nor anything in Andromeda can observe, executing the arithmetic that was set in place 13.8 billion years ago. This is not tragedy. Tragedy requires a protagonist who deserves better. The universe has no concept of what anyone deserves. This is simply what the universe is doing. It has been doing it the entire time. Here is what you are made of. The carbon in your body was forged in stellar cores, in stars that died before the sun existed, in supernovae that scattered their synthesized elements through the interstellar medium, where they were swept up into the molecular cloud that became the solar system 4.6 billion years ago. The iron in your blood was made in the explosive core collapse of at least one massive star, possibly more. The calcium in your bones, the oxygen in your lungs, the nitrogen in the proteins that fold and unfold in every cell of your body, all of it forged in stellar interiors, scattered by stellar death, assembled over billions of years into the molecules that constitute you. You are the universe's material, organized by the universe's processes, into a configuration capable of modeling the universe's behavior. The atoms in your left hand were in a star. The atoms in your right hand were in a different star. You are a collaboration of dead stars. Some of those atoms, not many, but not zero, came to the solar system from outside it. Interstellar objects pass through the solar system. Comets and asteroids carry material from the outer reaches of the galaxy. The interstellar medium drifts and exchanges material across vast distances over billions of years. The specific fraction of your atoms that originated in what we now call the Andromeda galaxy cannot be calculated without information we don't have. But the fraction is not zero. The universe has been mixing its material since the beginning. The merger will continue that mixing. The distinction between Milky Way matter and Andromeda matter will dissolve over billions of years of gravitational stirring in the merged galaxy. Whatever consciousness exists in the merged system in 10 billion years, if any does, will be made of atoms from both. The boundary between us and the thing coming toward us is already more porous than we know. We are not separate from what is coming. We are, at the atomic level, already partly what is coming. The merger is not the arrival of something foreign. It is the reunion of material that was distributed into two separate systems at the beginning and is now converging back through the inescapable logic of their mutual gravity. There is one more thing, the most unsettling thing. You cannot know what the universe looks like right now. Not just Andromeda, everything. The nearest star, Proxima Centauri, as it exists tonight in this moment in the universe's actual present tense configuration. You cannot see it. The light showing it to you is 4.24 years old. The star itself, the real star, the present tense star, is invisible to you. You are seeing 4.24-year-old light and calling it Proxima Centauri. The Andromeda galaxy as it exists tonight, invisible to you. The light showing it to you is 2.537 million years old. The Virgo cluster, the nearest large galaxy cluster, containing thousands of galaxies including the Virgo elliptical M87, which hosts a black hole 6.5 billion times the mass of the Sun. The light showing it to you is 53.5 million years old. M87, as it exists tonight, is invisible. The cosmic microwave background, the oldest light in the universe, the afterglow of the Big Bang itself, arriving at your detectors from a distance of 46 billion light-years, showing you the state of the universe 380,000 years after the Big Bang. The universe as it exists tonight at those distances, invisible. It will always be invisible. The light from those regions showing the universe as it is now will not arrive until the universe is far older than it is tonight, and whatever exists to receive it will be unrecognizably different from what exists tonight. You are living at the center of a sphere of past events. The sphere extends outward in all directions, and the further you look, the older the information. At the edge of the observable universe, you are seeing 13.8 billion years into the past. At no distance, in no direction, can you see the present. The present is always exactly one edge ahead of observation, always the thing that the light has not yet arrived from, always the state of the universe that is real but invisible, always the river as it is now rather than as the photograph shows it. This is the universe. This is what it is. This is what it has always been and what it will always be for as long as physics operates the way physics operates, which is to say, forever. Slipher opened the shutter on September 17, 1912. The plate developed in the dark. The spectral lines were shifted toward the blue. He measured 300 kilometers per second. He measured the past and called it discovery. He was right to call it discovery. The past is all there is to discover. The past is all there is. The present is always the next thing, never the thing you are looking at, never the thing arriving at your detector. You are reading these words in the present. By the time you have finished reading them, what you read at the beginning is in your past, and the words you have not yet reached are in your future, and the words you are reading now, this word, are the only present you have, narrow as a blade's edge, the frontier between what has arrived and what has not, and it is always moving and you cannot stop it. And neither can anything else in the universe, not galaxies, not mathematics, not the most powerful forces ever measured. The present is a knife edge between the past and the future, and the knife is always moving, and Andromeda is always on the future side of it, falling toward the knife at 110 kilometers per second. Until it isn't. Until it crosses. Until the light from that crossing begins its 4.5 billion year journey toward whatever is here to receive it. The knife moves. The galaxy falls. The light travels. The door closes.